We have the trigonometric functions, and we'd like to be able to graph them. So we're going to start with the graph of the sine, y equals the sine of x. To graph this, I'm going to start off by noting the period of the sine function, which is 2 pi. We know that the sine function completes a full rotation around the unit circle. In 2 pi, it hits everything that it needs to. So I'm going to say, well, from 0, I'm going to make the end of this here 2 pi. Okay, because I know I'm going to need, will be one full period. All right, let's talk about the, let's look at the unit circle to help us see what our graph will look like. So remember that the sine is the y-coordinate on the point of the point on the unit circle. So at an angle of 0, the y-coordinate is 0. Okay, so I'm going to have when x is 0, when x is 0, I have the sine of 0 is 0. Now, there are a few easy points, right? The axis points are really easy. So at this angle of pi over 2, our y-coordinate is up at 1. So pi over 2, which will be right here, the y-coordinate will be 1. And then I come down here, and this is an angle of pi. And at pi, the y-coordinate is 0. So here at pi, the y-coordinate is 0. And down here, this is 3 pi over 2. 3 pi over 2. The y-coordinate is negative 1. And then when I get a full revolution around at 2 pi, my y-coordinate is back to 0. So these are some points on the graph. But there's others. Okay, for example, we could go through any of our angles, the pi over 4 angle or the pi over 6. I'm going to do the pi over 6. The pi over 6 angle, okay, the y-coordinate there is 1/2. So at pi over 6, which is about a third of the way through this box, we're going to be up at 1/2. Okay, so there's a point. And we'd actually have the same y-coordinate over here at 5 pi over 6. It would be right around there. Okay, and we could continue kind of in that manner at 7 pi over 6 and at 11 pi over 6. Okay, and that starts to give us a picture of what's happening here. We have a nice curve, so like a little wave. Okay, that is the graph of one period of the sine function. One period of the sine function. Now we can continue. We can rotate in the opposite direction, and that's just going to repeat this shape. Okay, this period, this shape just gets copied over and over again for the graph of the sine. Just goes forever and ever in that manner. That's the graph of y equals the sine of x.